So I've heard a lot about this school. It's nice to be here finally. You know, I see always people coming from this school to New York or other places where I am, so it's nice. And actually, I have a funny story because I've been here only once, and I was telling Ashley today, that was when I worked for Peter Eisenman in '92. We were sent with 3 project architects to Columbus, Ohio to study Form Z, if you remember that ancient software, to get instructions from the developer. You know, the guy who actually designed that software. So that was my only 4 days ever in Columbus, and it's a while ago. So I'm happy to be back. I think the first thing I always start with, because I saw these posters in my head in the hallway, which is kind of embarrassing, is of course that we don't, you know, we architects, we don't work alone. We have a dog in the foreground, very important, she does models, and we have some other people who work with us. And hence the name of the office, Architectonics. I always decided that the office should not have my name because obviously teams are important, and especially in architecture, we actually do nothing as a person alone. The other thing that struck me today is I was told today that usually you guys get lectures from more theoretical people, and that finally they decided to get some people who build something, which means we're not theoretical. So I'll be very abstract about my theories. So yeah, here we are. The first thing I maybe want to show a little bit is what we do kind of think of in the office, just to counter that argument. This is a book which came out with Princeton Press in 2006, and the idea of the book is that we as an office believe in networks, not only in the way we work with other people, but also in the way we work in the office. So the idea is more to have a network of experts in the office, that everyone has their own input and that we work that way, but also that we like to work with other people like MIT Media Lab, or we have some scientist friends in Holland, since I am originally from Holland. That's the way we like to try and advance the way we think about buildings, and I'd like to talk a little bit about that today. The other thing is maybe that our research, and this is interesting when you do a book, the editor of Princeton Press actually noted that to me at some point. Is like, you know, it's interesting that your work goes through fields of research. And as we were talking about that, it is actually very, very true. And I think, you know, if you guys ever start an office yourself, you'll hopefully find that as well, is that you have focuses which stretch over a longer time than just one project. So let's say a few years, our first few years was actually thinking about the theme which was just mentioned, confluence. The first few years, we're really interested in how architecture is inflected by urban systems and vice versa, which we called interface. We did a lot of urban studies, but also a lot of buildings, which were kind of very inflected or influenced by cities and city systems. I think, you know, the interesting thing of a city is that it is a set of systems. And then the next thing we looked at was intelligent surfaces, or what we called smart skins. The idea that a surface is no longer 2-dimensional, but maybe 2.5 or 3-dimensional, that you can occupy it, that it can have intelligence, embedded technologies, and all kinds of performances. And then the last thing, which sounds a bit more abstract, is armature, and I'll talk a little bit about that as well. But armature is more the kind of 4-dimensional version of a smart skin, so maybe a smart object. Okay. I have one big influence, I think. It's always interesting to think about those things, or maybe two. But one is Gilles Deleuze, who has written a lot, and you could say maybe he's a projective philosopher. The idea of philosophy is usually you go back in history, you discuss ideas which were before, and then you kind of discuss the old ideas again in a new way. He kind of was one of the first philosophers who actually counteracted that with another idea, is that you can actually pose an idea in the future and then philosophize towards it. And one of the things he wrote was this statement, which I really like. The first real challenge lies in the statement and creation of problems, the right problems. So not just a problem, but the right problem. The second challenge lies in the discovery of genuine differences in kind. And the third, in the apprehension of real time, as in immediate. He wrote this in 1988. This notion of the right problem, as discussed by Gilles Deleuze, prioritizes concept development over problem solving, curiosity over absolute knowledge, and immediacy over stasis. This investigative approach has been redlined through the research and design conducted over the last few years at Architectonics. The work can be described as an open network, a network of projects linked through these three fields of research: armature, surface, and interface. These fields are not isolated, but rather create a synthesis of interests that overlap and inform each other and afford a rethinking, reinvestigating, and regenerating of architectural concepts. The focus is not on form, but on the performative, not on aesthetics, but on intelligence. Surface, in the second and half dimension, is the recording of behavioral processes in surface inflections and transforms the wall or the facade from a separative device into a connective membrane, a smart skin. Edmund Husserl names these things thing shapes. Specific to these thing shapes are their surface registrations that strive for gradual perfection. An essential form becomes recognizable through a method variation. What I'm doing today is basically running you through what we do in the office, which goes from objects, which is this, and the last project is an urban design. So it's kind of interesting to see, you know, and that doesn't necessarily mean that this is the first thing we did, and the urban design is this actually came after the urban design, so it's a non-linear, time-wise, a non-linear process. This was a light we designed for a lighting design company, obviously. I'm not going to talk too much about it. It's about surface. This is one of the first buildings we built. And that's also what I decided was the idea of the book was to actually do only a book after we built some buildings, so we waited a while. But this building was interesting in the sense that what you see here is this was an existing warehouse of 6 stories, and rather than tearing the warehouse down, we decided to keep the warehouse and to fold a 12-story building around it. And to think of the building code as an idea of recoding. So not so much a building code as a restriction or something you have to fight or some weird thing which is going to make everything impossible, but to kind of think of it as something really interesting, and obviously if you read it really well, you potentially could get things back out of it. So consider it a game. But the first thing we discovered from the building code is that actually these setback codes in New York, they're actually not based on a setback code as in steps or the wedding cake scenario, but as you see in this little tiny diagram, I should use this thing. This tiny little diagram, it was an inclined plane. And in the end, what we did was use mathematics, the idea of mathematics in inflection, and to inflect this inclined plane on the straight plane and vice versa, which then gave us kind of a rippled facade which would go equally from the top to the bottom. And would kind of intersect with the extruded volume of the existing building. So you see this little cutting device here, and then you get a building. That's where we are then. And then the other idea was to kind of create these folds, as you see here, really as folds. So we, after a long kind of investigating moment, we had the glass folded in Barcelona, the mullions extruded in Hong Kong, and the whole thing was put together in Brooklyn. And then, of course, you have these very brave people who hang out of windows and put these huge things in place. The way we did that, and it's maybe interesting for you guys, since you all work in 3D software, is that we designed everything 3D. There's no measurements on these drawings, not in the sense of, you know, this is this long and this high, but it's all work points. So basically X, Y, Z coordinates in space. And those drawings, 3D drawings, were sent to Barcelona and to Hong Kong. And those people actually made a 2D drawing. So it's quite an interesting way of working. And also what's maybe interesting also is you cut out the contractor. So nothing to do with the contractor. It goes straight to the manufacturer. And then the bottom of the building, I should probably go back one. The idea was also that this facade is this famous 3 dimensions. So what it does, every time it hits a boundary, like here on the street, it folds out and comes back as a big glass wing. Where it meets the building, there's balconies inserted and the glass folds in. And on the top, it folds up and over as it sort of dissolves in the sky, you could say, as a glass building. Then the sections of the entry wing constantly change. These are the extruded mullions. So as you can see, all these mullions have different angles. Only 5, thank God. And then that's the wing as it started to occur. So the other thing we did is we kind of completely separated the vertical and horizontal mullions, which made that the verticals we did in steel helps because you can weld it, and that was attached to the building. So the glass is actually floating off of these steel mullions and literally hanging down from the 8th floor to the ground floor. So on this level here, there's actually only kind of roller connections, so it's kind of really flopping around. This is a gallery in the building, and then the rest is residential. It's actually Surface Magazine who's in there. These are all the residences. We made the facade openable. It's, the building is built mostly with passive solar energy, a lot of renewable materials. It's not completely off the grid, but it's very, very low use in energy. And then here you start to see the folds as they negotiate. What was quite interesting in the folds eventually, and I didn't know this until we actually built it, is that you can literally look down through the glass of your little bent facade into the neighbor's living room, which is quite funny. It's kind of a voyeuristic building. And then this is the top. So this is really where that penthouse, as I said, comes up, over, and down, and it's the glass kind of parapet. And here you can see that that steel really carries all the glass, basically. There's no structure in the facade. All the actual structure of the building is held back, so the concrete is all cantilevering up to here. So the steel was really just supporting the glass itself. And this is then on the top. So you can see that the glass is just connected with little pins, like the wing on the ground floor was as well. This is then an interior. We mostly delivered this building in as raw space, which wasn't that raw. I mean, it was finished surfaces, but in New York, you can imagine we did this loft, which was about 3,500 square feet for one person, one guy, 28 years old. And then we did a loft on the second floor, which was 1,600 square feet, I think, for a family with one child. So, you know, in New York, it's very, very hard to predict anything, like who is going to have what. So we finished the spaces as surfaces, but we didn't put bedrooms in. This space we did for this person who is a painter and a photographer. And we made basically very simple, just one spine, which connects the east to the west facade. And behind that are private spaces. For example, this is the bedroom with a bathroom there. The wood is quite interesting. It's a bogwood. A bogwood is an oak which has been in the swamps, and hence it gets that really beautiful blonde and black pattern. So it's kind of a tree gone wrong, you could say. This is another building we just finished. It's a completely other market. It's in Philadelphia. Philadelphia is much more alternative than New York. It's a different market, different people. It was also built in Northern Liberties. Northern Liberties is kind of one of those industrial areas where artists start to live, galleries start, new restaurants start. So it's really great. It's kind of an alternative area. And of course, there also you can still park under your building, which probably you can here too in New York. If you can park, it's kind of really special. But here we had an area under the building. The little tiny dots here are the feet of the building. The core of the building comes down, and this basically is the parking, but we thought it was important that it became a park. So the surface where you're parking on is grasscrete, and then grasscrete can go from this pattern all the way to grass looking. So you can vary from here to here in the pattern. And the way we did that is that we actually only had the building standing on the ground on one side. So this is the only level where it's kind of zero. Then it folds up to +1, and the parking lot goes from 0 to -1. So there's kind of a slip between the two, which then kind of gives this very spacious area. The area it was built in is very small scale, so we decided to build the building from a set of Ls, interlocking Ls, so that it kind of started to fit more in the building. It's in the whole region, in the whole area. It's on the corner, as you can see here. A lot of people were calling this already a skate ramp. This had a perfect curve. And then the other curve is to be found where the building meets the parking, so it's actually right there where you go under the building. It's built in concrete, like in this school. I was just noticing today all the beautiful cantilevers you have. Well, that is nice because, you know, if you pour concrete, there you go. You have these huge cantilevers. This is up on top of the penthouse. And you get interesting cuts of the city. This is actually the city center of Philadelphia as you look out over it. And then this is the front where the building hits the ground. This is the facade looking down. The whole building is built in alucobond. I don't know whether you guys know that it's an insulated aluminum panel. That's why you can actually bend it, and it's very, very flexible because it has 2 skins with extruded foam in between. And then we use the size of the panel to make exactly the line of the windows also, so it kind of feels like a modular system. Then the same owner, next tower, is called the Q Tower. This is a tower where we work together with the MIT Media Lab. I was really interested in making a tower which would become more robotic. Or, you know, we talk a lot about interactive spaces. I was quite interested in turning that interactivity into something more, maybe more what your computer starts to do also. It's like basically like a software. It starts to learn your behavior rather than the other way around. And what we looked at with Ted Zelka from the MIT Media Lab is how you take all these known technologies as we all know them, right? From smart passes for parkings to sensors for lighting, sensors for which sense the sun and start to put blinds down, and to create and link all these technologies to a system which would then ultimately get more advanced. So here we're running through some of those. And then for the tower, what we, in the meantime, had discovered when we built the American loft is what was quite interesting about the facade there is that while we were pouring the concrete, all those facade elements were made while we did that. So when we were done pouring the concrete for the building, 3 weeks later, the facade was up. So we thought that was quite an interesting thought. And then the next thought was, if you build a tower, why couldn't everyone have a different house? Like building villas in a tower. And is repetition really that important if you have the possibility to put these facades in parametric softwares where you could actually all have your own individual apartment? So what we did is we just devised a very simple set of algorithms you see here, which were simple rule-based systems which would define a freedom where you could start to rate each opening in the building relative to the function and then give it deviations and restrictions in how they would start to negotiate each other. And what happened ultimately is that it was possible to kind of create different windows to different spaces, but still the main premise would be that every space, including bathrooms and kitchens, would have windows. The other one was what I thought, and that's probably my Dutch background, is that I always think it's kind of weird that you only have penthouses on the top. I personally don't like being on the top. I like being on the second floor. So what about if I ever got money? I would have to live in a small apartment because every tower is built with small apartments on the second floor and then they get bigger to the top. So I convinced the owner to do 5 penthouses, 2 on the top and 3 distributed through the building. So that eventually, like if you wanted to have a nice big duplex but on the 5th floor or on the 8th floor, it would be possible. So this kind of worked itself into this little tower. It's a very, very small site. It's literally the site of a plot in a normal urban environment. So I think it's about 25 by 100 feet. And this is the parametric software we started to put it in. It's the limited version of CATIA. Frank Geary's office developed the digital project. You probably use it here. And that made that we could make the quite random design we made in the beginning. We started to see similarities, and we found families of components which could then be repeated and basically sometimes mirrored. And through that, you could have a complete random system, but still not have, 6,000 different molds to make. So these are just some technical things. On the ground floor, we had a restaurant. What we did with this is we went half a floor up, so that if you go half a floor up, you're in the restaurant, and the parking behind, the inhabitants have their own entrance from the other side. I think I don't see it here, but this is basically the restaurant here. This model, we have our models made in Singapore. They have great inhabitants, I'll show you them. Like here, these people. They also only have sports cars. It's really great. And we have Superman also living here. It's quite cute. And they also glued really strongly, so we couldn't get them out. So we decided to just give it to the owner. I think they're still in. No one really noticed, but they're very, polished looking. So then we got interested in armatures. The person who I just mentioned, Edward Husserl, you might not know him. He's a philosopher in mathematics, 1937. He wrote a little book called The Origin of Geometry. And he wrote something on four anomic shapes. And four anomic shapes, to me, are very interesting because they are not only three-dimensional, more interesting, maybe more biologically formed organic spaces, but he sees them as spaces which potentially have the capacity to create other spaces. And to me, this is what you see here, from which new constructions grow. So the idea that you make something which ultimately can generate something else. We're very interested in, and I actually forgot to put one house in there, which is kind of a more intense example of this, but if you buy the book, you can find that. But I'll show a bigger example here where we started to think of the whole interior of the, in this case, hotel as a really intense knotted space. This is again the building code kind of decoded. And then the bottom result you see here, how the whole space in a way is one huge intertwining knot, which allowed the condominiums on the top and the hotel functions both to use the more general functions which are actually located in the knotted part, which you can see here. So the idea of this kind of armature is that there's a really intense intertwined space. The knot and the unknot is another mathematical principle, right? It's the fact that you can knot things, but we don't have two ends, but always loop back to each other. And then here, the tower, one second, has this, the entrance on one side. We should have turned it around on the other one, but on the other end, you get another part coming out, which is the pool. And then around the kind of interior courtyard, you get all these public functions which are focused around this crystalline space. The rooms are basically all divided through the two arms, and the apartments are here on top. The pixelation, I don't know, yeah, you can see it. The pixelation you see here is literally a registration of the proximity to the lot line. Very simple rule, if you write on the lot line, you can have 10% glass, and as you move away, you can have more. And because we had this kind of diagonal shape, which constantly moves from the lot line away and then loops back, it's quite nice that the facades picked up that pattern as you register the proximity. So that's why there's kind of this graduation or gradation of the pixelation. The pixelation is stone and glass, so basically it's a stone and glass tower. And of course, because of that big opening in the middle, sometimes you have two different towers, and then they connect back to one. And here you see the big public space. So the idea is that if you come in through this arm, you get a 5-story lobby. The ground floor lobby is connected to meeting rooms through a big ramp, which is also the ramp of the parking garage below. The spa is suspended here, and this is a 2-story restaurant which has a terrace in the inside of the building. Let's see the other side. And this is that kind of armature in the middle, which kind of starts to connect all the different spaces inside and start to connect the different floors. You see that here again. And this is actually the restaurant here. This is then in the terrace. So here, the terrace, you start to be kind of inside of that glass area. The registration of the whole loop, we gave a pattern of kind of a large forest. The interesting thing is you only see the forest if you zoom out. So if you're actually in your room, you see only a few dots. But if you look down on the roof of the pool, you would see kind of more of a pattern. Because we chose the pixels, as you see, very, very large, so that there's no real pattern. It's more of a kind of a dot system. This is in the restaurant looking up. And then this is back to the entrance of the hotel. This hotel is a 5-star hotel. It's for the GHM group. It's probably the most well-known parts of that hotel is the Setai in Miami, or the Cherry in Milan, or the Alamandar in Bali. It's an Asian group. It's quite interesting. Very, very, very high-end. The interior designer is from Bali, so it's going to be quite an interesting contrast. I wouldn't want to do the interior, to be honest, in this one. But we thought of one here. Because we had to solve, this was quite interesting. So you make a building with a 45-degree glass facade. And we did that because we built basically, as you understood, the full building envelope. So you get interesting areas. And we thought it would be beautiful to kind of have this as a wood deck with plants in it and then your baths, right? So that if you're sitting in your bath, you can kind of contemplatively study the clouds going by. It's very poetic. And it has automatic blinds going down just in case, a bit glary sometimes. Then we do, so while we're working on bigger projects, we also do very small projects. This is a townhouse in New York City. That is a landmark area. So the front of the building here is actually a very standard landmark, little townhouse, nothing special. From here, everything was gutted and taken out. And we have added 12 foot to the building, as you can see here. So this basically is added to the building. And the back facade is completely new. So it's quite an interesting thing to build a completely new building, but reversed. You will never see it from the street. And actually only people in the courtyard will ever see a new building. So, but the concept was to kind of rethink this facade, like a little bit like we did with the bigger Greenwich building, as a three-dimensional zone, and where you would be really connected, so that the husband is a writer, he's working here, the living room areas are here, so that through these kind of glass floors, you would always have contact with each other, and then it folds back as a big terrace here, bedroom and 2 bedrooms up here. So that kind of the idea that the whole building has these intertwined zones kind of fluctuating around the facade rather than the facade being a separative membrane. Here you see the studies of kind of very spinal elements. It was quite funny. I had to go through landmarks. Imagine landmarks in New York is kind of a whole group of serious historians and preservationists. And here I come with these kind of things. No? It's kind of an interesting battle. So we hired a historian because we thought we have to become historical on this thing. And he called it a Victorian tea porch. So I actually had to look up what a tea porch really was. I'm from Holland. We don't have teas and porches and things like that. We just go ice skating or sailing. So yeah, I got very well versed in the whole story. We explained it and they loved it, which was really thanks to him, because I don't know how I would have explained this otherwise, except for the fact I'm really interested in 3D spaces. And you know, the other thing which is fascinating is that this thing is made with this machine up here. The other people we work with a lot, apart from MIT Media Lab, is a car design company in California. And they have this huge CNC router thing where they can basically cut a whole car out of foam. And when I taught at Harvard last semester, and basically I asked him to come and talk to the students, we were thinking about building components. And then he wanted to see my office to basically explain him this facade. And I was like, I'm not quite sure how I'm going to make this, except for send it maybe to Bali or whatever. No? And he's like, are you kidding? I can stick this in my machine because it's less than 20 feet wide. So this is going to be made in 3 pieces. He can basically make this whole bit in one jump, this whole bit in one jump. It's going to be linked over these lines here. And then the top in another jump. So it's quite an interesting, and it's made out of recycled wood made from old boats, actually, which we get from Bali. In the end, something came out of Bali. Here you see the studies. As you can see, we have the 3D printer you probably have here as well, where you basically print 3D models. We did a lot of studies, like to kind of figure out whether we could kind of show it more as a force field to see whether these forces in the facade could register in the surfaces. Sorry, go back one. Here on the upper thing, we have seating also built in and a planter in between these 2 levels. And then, you know, how to sit in the glass. I didn't want to have an aluminum facade in a wood facade. So we're really considering the wood as a big, huge window where we put the glass straight in, which is kind of safer because if you had more materials, it would be kind of tricky with expansion and all kinds of other things. Here you have some more details. We like the detail, obviously. We really do sit there endlessly figuring it all out. So here you have the area looking down through these glassy areas and you stare down. The other really interesting thing is how you make actually this wood, because obviously you can't have these huge chunks of wood. So you can choose whether you want to laminate the wood beams this way, or whether you show the flame. So it's a really interesting study, because we actually did some different ones where you either get a stripy pattern or you get all the variations. Huge difference, big decisions. The big decisions in the small days. Here's the facade if you look up. And you can see the neighbors. It's quite a, you know, I always wonder, like here we have all this struggle to go through landmarks and then they have this next door. It's kind of, I actually said that, I think, in the landmark meeting when I got really irritated. They're not very sensitive to those kind of details, or remarks for that matter. So here you, here you get the seating and the plants. It's quite nice because it feels like very, very open. We have the wood running into the space also, so you have this continuity of in and outside. It's a very protected back garden, so potentially you could have these facades open all summer. And then this is a huge project we're working on in Brussels. Very, very interesting question. A client who found a tunnel, a traffic tunnel, so car tunnel, which is kind of half of Avenue Louisa, which is a big, huge shopping boulevard in Brussels, and the tunnel is only half the boulevard. So this is quite an interesting, clever idea. He has proposed to the city to elongate the tunnel and pay for it, and in exchange to build on the tunnel. So now he has free construction ground versus, you know, the city getting a tunnel. So everyone's kind of happy with that. And then they asked us to make 10 pavilions in a park on the tunnel. Not that easy. It's kind of interesting because you can't make foundations, as you can imagine, and you can't put any load on the tunnel, which is another problem. But what we thought was really important is to make the inside spaces as important as the outside spaces. So not to design buildings with interiors, but to consider the interior of the pavilion, the interior of the park, all interior. So what we did is we took a little sound piece, took the frequencies, this is also nice about Maya, and then inflected these frequencies on shapes where this started to occur. There's a lot of work in between these two, you can imagine, but I don't want to bore you with all the details. But what happened is, so the idea is really that these exterior spaces, the green spaces, are as designed as the interior spaces. The other thing we thought is that when you start thinking about this project is that the moment you listen to a developer, which we kind of try, is that there is very little green space. So the other thing we did is that we made greenhouses inside of the pavilions. Because I thought it would be really beautiful if you could imagine that one shop was separated from another, whatever, gallery, let's say, through a greenhouse full of orchids or bamboo or something like that. And at the same time, we made the roof so they collect water, and there's retaining tanks, and it's kind of an automatic irrigation system. So both the park and the greenhouses are irrigated automatically. We made a whole path for gardeners, you know, how they can garden the outside spaces, the inside greenhouse spaces, and keep walking through the park. So this was the proposal. It's pretty low. It's like sometimes 1.5 stories, sometimes 2 stories, and a story below ground. And the other thing is that we thought of all kinds of ways of making green without needing ground. So we have suspended green, we have self-dissolving green, we have all kinds of green. Here you start to see a little bit of it. These are actually big, huge mesh shapes which have hanging green. You'll see that in a second. And then these interior spaces. So there's basically always these kind of fluid connections. And the greenhouses, you don't see them very well here, but they connect obliquely through these volumes. So the gardener actually has more shortcuts than the normal pedestrian. And here you see a little bit of a section. So the car traffic, there's also a subway to make things more complex. Then we are kind of half underground. We made these all double heights so that when you're in the park, you can look down and you have light. And then here you see one of those gaps with the greenhouses. And the way we actually developed the whole skin with an engineer from Holland, who is the first person who developed free-span concrete shells. Very old man. So the whole idea is that there is no structure in the skins at all. It's basically free-span. It has lots of little perforations, so there's daylight coming into the spaces. And that these kind of systems stand almost like tables or like freestanding structures within the big shells. So it's kind of a complete other way of thinking, because as you can imagine, this was not that easy to build on. Plus the sewers, whatever is in the ground, lots of things in the ground. Here we have the suspended gardens. So the idea is really to kind of create that as a really important element. Between this and this suspended garden is actually another cafe. So we use the spaces occasionally here and here also as different cafes or different exhibition spaces. And here you see our inspiration for green things. We got carried away with the green thing. And then you start to see how these spaces start to develop. It's quite interesting because these are very, very beautiful old townhouses where we actually also did a proposal for one of those. This is the meshy forms. These are actually stairs inside of here where you go to the restaurants below. And then they came to us and they said, we would like 3 squares. And we would like an ice rink like Rockefeller Center, but bigger. So here we go. This is the ice rink. And it's a third bigger than Rockefeller Center. In the winter, it is really a nice skating rink. But in the summer, we dry it up. And we use it for projection of movies so that people can sit on the steps, these steps here, and actually, or, you know, whatever, dance events or whatever other events. Because that much water in a very wet climate is not that easy, actually, funny enough. And then this is another square where there's a fountain. This fountain reacts to the sound of the traffic. So if there's lots of traffic, you have lots of fountain, and if there's no traffic, you have no fountain. You have to be rigorous about things, I think. But that's the idea, and it's also like it's just a perforated skin, so it's like a big whale in the ground, and the water really only comes out in certain patterns and sporadically. So theoretically, if you don't mind getting wet, you could walk over it and, you know, have the fountain around you. So it's kind of the idea of being a bit more easygoing about what a fountain is or what an object is or how you want to treat these kind of surfaces. That's it. Thank you.